Assalamu alaikum everyone, I hope you all are doing well and taking good care of yourselves. This is your instructor Ali Faruqi and you are watching Science with Ali. So in today's video we're going to be taking a look at chapter 2 of our Cambridge syllabus, Cambridge O-level syllabus, which is elements, atoms and compounds. Now this chapter is particularly a very confusing chapter because it contains various topics such as bonding, atom configuration, structure of an atom, etc, etc. But in today's class we'll be taking a look at the differences between elements, compounds and mixtures, their structures, the relative charges of the protons, neutrons and electrons, and we're going to be discussing some basic terms, right? So let's get started with the class. Okay, so the first thing we have is elements, right? Now an element is a pure substance made up of only one type of atom, right? It is the simplest form of matter. Elements are represented by chemical symbols such as O for oxygen and H for hydrogen. This is just an example. You can find these other examples in the periodic table as well. Now there are three boxes that are drawn over here. One is for an element. I'm representing E for element, C for compound, and M for mixture, right? So now we're going to be discussing the various differences that are present in the three boxes, right? Okay, so there are a few properties of elements which we need to discuss. Let's get rid of this first, right? So the first property that we have for element, let me just tell you a fun fact first, that there are about 118 known elements, each with its unique properties, right? So elements contain one type of atom. Okay, so one type of atom. And elements cannot be broken down. Alright, so an element cannot be broken down into simpler substances. An oxygen molecule which we have over here, O2, right? So this is O2, which I have labeled right now, right? An oxygen molecule is an example of an element. This element is a molecule composed of two oxygen atoms bonded together. So the element oxygen consists of only oxygen atoms. The element carbon is made up of only carbon atoms, and so on. Now moving on to compounds, right? So compounds, the compounds are substances formed when two or more different elements chemically combine. So let's write this down. We have the first point, 2 plus different elements. It can be 2 or it can be more than 2. So 2 plus different elements. Let's write this down. 2 plus different elements chemically bonded. Alright, so compounds can be represented for formulas by chemical formulas such as H2O, which is the water molecule, and CO2, which is carbon dioxide gas. Now, they have distinct and unique properties different from elements that make them up, and compounds cannot be separated physically, and chemical reactions are needed to break compounds into their individual elements. Now, water and carbon dioxide are examples of compounds. Now, water or H2O is a compound. Water or H2O is a compound which is composed of two hydrogen atoms and one oxygen atom chemically bonded together. Carbon dioxide is a compound consisting of one carbon atom bonded to two oxygen atoms. Now I have drawn the water molecule over here. As you can see, I have selected it over here. Now if I draw a carbon dioxide molecule, it's going to look like something like similar to this. This is the carbon in the middle and the oxygen atoms are green in color, right? I think this is pretty clear. Okay, so that is elements or compounds. Moving on to mixtures. Now, mixtures are combinations of two or more substances. They are not compounds, they are combinations of two or more substances, that is, elements or compounds physically mixed together but not chemically bonded. For example, if I give you an example of if you try to mix sand in water, it won't dissolve, right? You can just separate the sand from the water by using a filter paper or using a sieve. If you have a very good sieve at home, you can use that as well, but it is not chemically bonded. You can separate it physically, right? So this is a very important factor. Mixtures are combinations of two or more substances. Let's write this down. Physically mixed. They are physically mixed. Right? They are physically mixed and they are not chemically bonded. Okay, I'm getting better at this stuff. Right, so the components in a mixture retain their individual properties. As I said, they can be separated by physical means such as filtration or distillation. I can give you an example of the salt, right? Salt water, when you dissolve table salt or sodium chloride, you create a mixture. The salt doesn't chemically combine with water but is dispersed through it, right? Okay, so now that that's out of the way, we can now focus on the differences between the compound, the element, and the mixture, right? So let's simplify the differences. Now, an atom, think of an atom as the smallest indivisible unit of an element. It's a single type of particle. This right here, this blue thing that I have highlighted over here is an atom, right? This is an atom. It's a single unit which is drawn on the screen right now, right? A molecule is a group of atoms bonded together, right? So this right here, this red thing, that is a molecule, right? Now, molecules can be made of atoms or of the same or different elements, which I discussed earlier in this class. So this is a molecule, and these are also molecules. These and these are molecules, right? So a compound is a specific type of molecule. It consists of atoms of different elements chemically bonded together. So even though this is a molecule, it is not a compound. These are molecules and they are compounds. Not all molecules are compounds. Some molecules consist of atoms of the same element bonded together, like oxygen gas, which is not a compound. Compounds specifically refer to molecules with different elements. Let's write this down. So I think this is a bit confusing. I didn't clarify it that much. So a compound is basically, we can say that compounds refer to molecules with different elements, made up of different elements. And a molecule is made of same elements, right? Made of same elements. So this is an atom. That is a compound. And the red one is a molecule. Right. All right. So I think that's pretty clear. All compounds are molecules, but not all molecules are compounds. Let's write this down as well. All compounds are molecules, but not all molecules are compounds. Wait, terrible handwriting, I know. I'm working on that. All right, so this is pretty easy. It's not confusing at all. Just think of it this way, that if you have oxygen gas, it's a molecule because it's the same type of element. And if you have HCl, for example, which I've drawn over here, that is a compound because it's made of different elements. So now let's dive into atomic structure and the periodic table. Okay. Now I have written the definition of atom on the screen here, which says that an atom is the simplest unit of matter that makes everything around us. Atoms are the basic building blocks of all substances and come in different types known as elements, such as carbon, hydrogen, oxygen, which we discussed earlier in the video. Now an atom has a center called the nucleus, right? So this is the nucleus. This is the shells. These are the shells. And these are the electrons. The green circles that you see on screen are called the electrons. Right now, and around this center, electrons are arranged in energy levels or shells. Right? The electrons house themselves in the shells. Now these electrons orbit the nucleus. They go around the nucleus and they stay in orbit and go round and round in the nucleus, right? So atoms consist of subatomic particles known as protons, neutrons, and electrons, right? So in the central core of the atom, which is the nucleus, there are two types of protons. The two types of particles called the proton and the neutron, right? So location of the proton and the neutron is the nucleus, right? Okay. And the electrons are housed in the shells. Now this is a neutral atom, because if you count the protons and electrons, we need to figure out the charge first. Let's figure out the charge first. So the proton has a charge of +1. The electron has a charge of -1, right? And the neutron has no charge, right? Neutron has no charge. Alright, so this is a neutral atom. As you can see here, the blue ones are the protons. So these are the protons, the blue circles in the nucleus. As you can see, there are 6 protons present in the nucleus. Now I have 6 electrons as well. 1, 2, 3, 4, 5, and 6. So this right here is deemed as a neutral atom. Now if there is a difference in the protons and electrons, for example, if there is more protons than electrons in an atom, it means there is an ion. It is an ion. Now we'll get to ions in the next videos, but just to clarify one thing, that we will be studying ions and it's not that difficult, so I just thought I'd get rid of this right away so there's no confusion later on. Right, there's something called mass also in the proton and neutron, which is they have a mass of 1 atmospheres, right? 1 atmospheric unit. The AMU stands for 1 atmospheric unit, right? And the electron has a very low mass because it's very smaller and has a mass of 1 divided by 1836, right? So if you calculate that mathematically, it's very small. Okay, so if you look at the periodic table, this tile is present in the periodic table. If you look at it carefully, there's 1 number at the top and there's 1 number at the bottom. Now these numbers have a meaning to them. The bigger number is called the proton number. Sorry, the smaller number is called the proton number. I'm so clumsy of me, I'm literally sleeping right now. So proton number is the smaller one, and the mass number is the bigger one. Right. Now the proton number or atomic number is the number of protons in the nucleus of an atom. The atomic number is represented by the letter Z, right? The number of protons will always be equal to the number of electrons in a neutral atom, as I discussed earlier. The atomic number also helps us identify where the element is located on the periodic table. Each type of atom is characterized by its unique number of protons. That is what is known as the atomic number. For example, all atoms with 6 protons are carbon atoms, right? So please note that on some periodic tables, the numbers may be arranged differently, but remember that the atomic number is the smaller of the two numbers, whether it's at the top or it's at the bottom. This is very important because what happens is that the CI examiners, what they do is right now is they switch the numbers from top to bottom. Now the student, what does he do? He remembers one thing, that the mass number was at the top and the proton number was at the bottom, so he mixes them up, right? Don't do that at all, right? So let's get down to business again. Okay, so let's write this down. Proton number is number of protons and electrons. Number of protons and electrons, and the mass number is called protons and neutrons. Right? So the mass number contains the protons and the neutrons. Okay, so we have some important calculations which we have right now, which is to calculate the neutrons. This is a question that does come in the exam. So we need to calculate the neutrons, right? So calculation of neutrons, what will we do? We will subtract the mass number from the proton number to get the neutrons. So we have the mass number, which is 12. We have the proton number, which is 6. So we get the neutrons as 6. Okay, so this wraps up our part 1 of atoms, elements, compounds. Now in the next class, we will be discussing more parts of this topic as well. We will be talking about electronic configuration and everything, and ions as well. So please stay tuned for that video. If you have any questions regarding this video, please drop them down in the comment section down below and I will respond to your queries. As always, I hope you enjoyed this video and I will see you in the next class.